Good morning, I'm Dr. Huang. Today, we're going to use electrolysis to determine the Avogadro's number. And this is what we need. I already get my notebook ready. I put on my procedures. I also designed a data table and a sketch to show the connections. And this is a LabQuest device. This will tell us current when we conduct the experiment. And this is the power supply. It will supply the electricity. And there are 4 beakers for this experiment. Therefore, this is good for 4 people to use the same device. And then we have some wires. We can make connections. We have a few items. One is nitric acid. The other one is methanol. That's why we put them inside the hood. So whenever you have a vapor or something, it can be absorbed by the hood, so we can be protected. Since for this experiment, we are going to use nitric acid and methanol. They're nasty stuff, so we have to make sure we are protected well. This is the safety goggles, so I'm going to put on the safety goggles. Okay, I will adjust, so make sure I feel comfortable. And then, these are the gloves, because we are handling nitric acid. They are concentrated nitric acid, so I want to protect myself with these gloves. I think I'm ready. I'm safely protected. Now I'm going to grab my beaker. I will let my partners grab their beakers. Obviously, they're not here. When you come to the lab, you will have lab partners. I'm going to grab my beaker, and these 2 copper strips, we call them copper electrodes. I'm going to go to the hood and then clean them and get the mass for both of them. Then I'm going to record the masses of both electrodes in my notebook. Are you ready? Let's go. And these are the 3 chemicals we need for this experiment. This is nitric acid. This is ethanol. I know I said methanol. Sometimes you can use ethanol as well. And this is copper sulfate. After we get the mass of both electrodes, we need to get some copper sulfate solution into this beaker. Now, what I'm going to do is I'm going to transfer some nitric acid into a beaker. If you come to the lab, it's already in the beaker, then you don't need to do this step. I will use my palm to face the labels. So whenever you get some liquid out, it will not etch this label. So it's still readable. Put it back. Then I'm going to get the 2 copper electrodes. And then this is what I'm going to do. I'm going to immerse this one and then stir a little bit for about 20 seconds. So if there's any oxide, it will be dissolved. So you will get a fresh copper. You need to do for both electrodes. If you get a larger beaker, you can do them at the same time. Okay, once I clean with nitric acid, the next step, what I'm going to do, I'm going to use ethanol to clean any possible stuff off the copper electrode. Make sure you don't get any chemical on your clothes or gloves, if possible. sometimes if you have some liquid on the electrode, you have to wait for a little while, but I don't suggest you to do like something like this violently, because you may get the chemical onto somebody. So, okay, then let's clean this piece. It looks it's pretty dirty, so, and the cleaning is very effective. We get some dirt off the electrode. Okay, the next step is I'm going to air dry this this ethanol. And sometimes you can do this like you're done thing, but make sure you don't get the chemical onto anybody. They may not be happy. Now we need to get the masses of the two copper electrodes with an electronic balance. This is an electronic balance. Make sure the electronic balance is on and the reading is 0. As we can see here, the reading is not 0. Therefore, we need to press the button in the middle. Make sure it is 0 before we place the electrode on the electronic balance. Now it is 0. Well, for the two copper electrodes, make sure the labels are different. One labeled A, one labeled B. Well, you should check this before you clean them. But if you check right now, you find you have two A's or two B's, you can switch with your partners. Probably your partner will get, if you get two A's, your partner will get two B's. Well, let's get the mass of electrode A. The electronic balance says 10.346 gram. We need to use a pen, not a pencil, to record the reading immediately. You don't go back to your station and grab your notebook and put down. You should have your notebook here, just next to the electronic balance. Let's put down the numbers. 10.345 gram. Now let's get the mass of electrode B. We will use the same procedure. Before we place the electrode on the electronic balance, we have to make sure the reading is 0. Now it is 0. Let's place this electrode here. The electronic balance says 14.010 gram. Now we get the two masses of the two copper electrodes. We are ready to move to the next step. We need to add some copper sulfate solution into this beaker. Follow me to the hood. Okay, this is the copper sulfate solution. It should stay inside the hood. And this is my beaker. I need to get some copper sulfate solution into this beaker. The criteria is you want to make sure these two copper electrodes must be partially immersed. So from what I have, I think I probably need 100 milliliter of copper sulfate solution. This should be more than enough. 50 will be a little bit too less, so I prefer 100. Okay, again, the total volume doesn't matter that much as long as the two copper electrodes are immersed. If you say, oh, I accidentally added 150, that's fine. You do not need to put it back. Okay, when you and your lab partners get the beakers ready, and then we are ready to go to the next step. We need to hook up everything. And since you have 4 people in a group, you have 4 beakers, a good habit is to write down the names of each person who are in the same group. Otherwise, what if you forget? One way to do this is use some labels. Put down your name, or if you have a marker, you can write down the name on the beaker directly. I don't have markers, so I'm going to use this label. I'm going to write down Dr. H. Okay. So then I know it is mine because I don't have lab partners. I assume I don't care about their results, so I just put on my labels. But when you do experiment, you should care about your own beakers. Let's continue to do the next step. We have a lot of wires. It looks very, very messy. So you have to pay special attention to what I'm doing right now. This is the power supply. This is positive. This is negative. Okay, generally, people want to use a red to indicate it is a positive electrode. So let me pick up a red wire. So this is red. I just plug in. There is a clamp here. I'm going to clamp here. Then I need a black to go to this side. So let me pick up a black. And this is black, and this is a clamp. When we do the experiment, we have to know the current that flows through the circuit. Therefore, we need like a meter to measure the current. And this is one of the meters, the current meter. And it has one input and one output. If you insert the positive, how do we know it's positive? Because it comes from the positive electrode. Okay, and this is the positive electrode. When we follow the electrode, it goes this way. And then this is connected to the positive. Therefore, this is positive. If we connect this one to the red, then the reading will be positive. But if you accidentally connect to the wrong side, like this way, your reading will be negative, but it does not affect your results. You can still get the results. Okay, in order to get the reading, this one has to be hooked up with a LabQuest device. This is a LabQuest device. I'm going to insert this one into different slots. Since all of them are available, so I'm going to insert into channel 1. You should hear a click. Now we can see there will be a current reading on the screen. Then let's close the circuit. We have to connect this side to the negative electrode. Then we will form a closed circuit. Well, I'm sorry because we have 4 people to work together. We cannot hook up this bag to the power supply. If you only have one person to use this power supply, then we let this to go back to the power supply. But if we have more, then we have to hook up with another beaker, which is your partner's beaker. And this is my partner's beaker. I will work this out for him or her. Okay, we will connect this one to A. When you hook up these electrodes, you don't want the 2 electrodes touch each other. If they touch it, then your experiment is screwed. Well, then we need another wire to let it go back to the power supply. Well, I think I want this one to be red because this is from the positive electrode. So remember, you want the positive to be red. So let's get a red wire. Okay, this side will be connected to the power supply directly, the positive. Then we hook this up with this electrode. And then the current will flow from B to A and then go back to the negative terminal of the power supply. If you have two people work together, then this is the setup. But if you have 4 people, then you have to hook up similarly as what we did for the other 2 beakers. Let me show you how to do that right now. Because this is already hooked up with the electrode. Therefore, I can plug in here. Okay, then I'm going to connect this one to electrode A. Then I need a black. Then I need a black wire to hook up with B. If it's moving, you can just press this electrode because it's very flexible. It will stick to the wall of the beakers. Then I need another current meter to measure the current of this circuit. Again, this is the same current meter we used as the other one. I'm going to connect to this side. Remember, this side is connected to the positive terminal of the power supply. So this will be the positive. This way, your reading will be positive. I have to hook this up with the LabQuest device, which is here, because I already used channel 1. I can use either channel 2 or channel 3. So I'm going to insert here. You should see a click. You should hear a click. Then, as you can see here, you say channel 1, channel 2. Make sure you know which channel your beaker is hooked up. Okay, then let's hook up with another beaker because we have 4 people in a group. Okay, connect here. And then I will use a clamp to connect to electrode B. And then I get another one, connect to A. Okay, and this one should go back to the negative terminal of the power supply. It should be here. Okay, this looks pretty messy. I'm not sure if you can figure this out by yourself, but you should. And another data you should record is how your beakers are connected to the power supply and to the meters. So I already showed a sketch. In my notebook. This is positive, this is negative. Then let's follow that. So let's find my beaker. Okay, this is my beaker, Dr. H. And then I need to find the positive. So this I will follow here. Positive connect to B. Positive connected. Well, positive connected to A, negative connected to B. And then I need to figure out which channel this one use. Okay, as we can see the connections. As I said, this is pretty messy. As you can see here, these are connected. So my beaker is connected to this channel. Then we have to follow this to go back to the LabQuest device. So let's follow the wire, and then let's find this out. Well, this is 1, so it is channel 1. So my beaker is connected to channel 1. So I put this channel 1, channel 2. Okay, and my channel, my beaker is connected to channel 1. So let's follow the positive. The positive go here and follow here. So this is my beaker, because when we follow here, the first beaker of channel 1 is mine. So this is my beaker. I put Dr. H. I put Dr. H here. And also we know that my electrode A is connected to the positive. So from this chart, this is the electrode connected to this positive supply. This is the electrode connected to the positive terminal of the power supply. So according to this one, it's connected to A. So I need to put down A here and B here. Okay, and if you want, you can also show your partners. But the most important data I want to say is your data. So you make sure the electrodes are labeled correctly to the correct terminals of the power supply, and make sure you label your channels correctly, because this reading really depends on which channel you use, that the reading may be different. We have to set up the data acquisition time and how often we acquire the data. Okay, so here is what you should click. Well, then you will see this screen. We still want time-based. We want 40 minutes. So if you don't have enough time for 40 minutes, you can set up for 30 minutes. Okay, we type in 40. We click done. And then the unit we change to minutes. And then the sampling rate, we want to be every second we want to get a sample. So for a minute, we should get 60 samples. Click done, and then click OK. Now let's turn on the power supply. But before you turn on the power supply, make sure you plug in to the electrical outlet. This is okay. Now we are ready to turn on the power supply. And this is what you should do. You can turn this on to the right. And then you need to look at your current very carefully. We want your current to be about 0.4 ampere. So let's do it now. I'm going to turn on here. And then at the same time, we watch the screen. Make sure the reading is about 0.4. Then I think we're ready to turn on the power supply. Okay, you watch here. And then at the same time, we turn this on. When this is 0.4 ampere or negative 0.4 ampere, then we should stop here. Okay, 0.39, 0.34. So it is fine. It doesn't need to be exact. But we need to record this this number, exact numbers. I mean, this device, LabQuest, will record the readings automatically. I do not mean you use pen to record these numbers. Because the experiment will run about 40 minutes, and this power supply will not turn off at 40 minutes. So what we should do is we have to make sure we are here at maybe 39 minutes and 40 seconds. Then when it's 40 minutes, we just turn it off immediately. But the data acquisition will turn off automatically. You do not need to worry about this side. If you forget to turn off at 40 minutes, it will introduce experiment error. But if you turn off early, like 39 minutes, your data is still usable. You don't introduce any experimental error. Now it's 39 minutes and 50 seconds. Now I think I'm ready. Let's turn it off. You see the current goes back to 0. Because any device, electronic device, will have electronic noises. So it will not be exactly 0. If it's like negative 0.0005 ampere, the digit only appear, the reading, non-zero reading, only appears on the fourth digit after the decimal place. It's fine. So it's essentially a 0. Okay, because our electrolysis did not last for 40 minutes. It only lasts for 39 minutes and 50 seconds. So we have to put this down in the notebook. Otherwise, we may forget. So this is my notebook. I already put on electrolysis time. So I'm going to put down 39 minutes and 50 seconds. (39 minutes, 50 seconds). You know, I didn't cheat. Okay, and then we need to unhook the beakers. Make sure you take your own beakers. You don't take somebody else's beaker. Let me see. Oh, yes, it's still my beaker. Okay, then we need to go back to the hood and clean this again and get it dry and get the masses of both electrodes. After we get the masses of both electrodes, we are pretty much done for this experiment, except cleaning. We have to do cleaning afterwards. Now we are back to the hood. So this is a nitric acid we used earlier, where we use the same solution. I will take out my electrodes and then immerse them into the nitric acid solution. Okay, if you have a larger beaker, you can clean them at the same time, so you can leave the lab a little early. So we need to do this for about 20 seconds. Let the nitric acid drip off the copper electrodes. Then we need to get the ethanol bottle. This is the ethanol bottle. Let me put this away so I have plenty of space. Then I need to get a waste beaker. This is the same beaker as we used earlier. So this is what I'm going to do. Let me put this to the inside of the hood. And then this is the ethanol. Let's clean any dirt off the copper electrode. Okay. Then we need to air dry both electrodes. We can wave them a little bit, like we're dancing. Now, okay, this will take about a minute or maybe 2. Then, when this is dry, we can get the masses of both electrodes. Then we are done for the experiment measurements. Okay, now we need to dispose the copper sulfate solution. Generally, when you take the chemicals out of the original bottle, you should never put it back. But this is a special case because we reuse this copper sulfate solution every year to save some money for the university. This is the original bottle. And make sure you check this bottle. You don't want to overfill this bottle. If you get some extra solution out of the bottle, somebody has to clean it. But it's probably you. You have to clean it before you leave. Nobody wants to do that. Okay, I think we are good. Now we need to get the masses of the two copper electrodes. This is the electronic balance. Make sure the reading is 0. As we can see here, the reading is already 0. Then what we can do is we just place the electrodes onto the balance. The mass for electrode A is 10.278. Let's record the number right now. 10.278. It is a little less than before the experiment. Then let's try to get the mass of electrode B. This is B. Make sure it's 0. We place B on top of the balance. It's 14.887 grams. Okay, as we can see here, electrode A lose masses. Electrode B gain mass. If you have two electrodes, both of them lost masses, then there must be something wrong. If you have both electrodes get increase of masses, then there must be something wrong. More likely, the mistake is you did not record the correct masses, either before the experiment or after the experiment or both. Okay, now let's disconnect everything. But for this step, you need to ask your instructor or the lab manager whether they want you to do this step or not, because our classes is one next to the other. They may need to hook them again if you unhook or if you disconnect everything. So ask your lab manager or instructor whether you should disconnect everything or not. But I'm going to show you how to disconnect this anyway. Okay, so we unplug the wires. And okay, we put it back. And let's look at this one. Unhook. Then we need to put back all the beakers into the plate. I think that's it, but do not forget to export your data from LabQuest. Otherwise, you will not know the current during your electrolysis. Now we are going to export the data from the experiment. Without the data, you cannot calculate the Avogadro's number. And you should get a USB drive for this class. If you don't, or you didn't watch this video, you probably don't know you need to bring a USB drive. This is the USB drive I borrowed from my friend, and you see how cute it is, but this is a USB drive. Well, say, you see that? And then look at here. This is for a USB connection. And then let's plug in. Okay, this is what you're going to see. And then click File. Then you will see some menu items. Then click Export. Make sure you click this USB icon. Then when you export the data, it will be on your USB drive, not on this device. Well, it seems that it's already on this USB drive. And click Export. Then what you need to do is you put a name for your file. Generally, you can put down the experiment number or your name or whatever you like, but make sure you know it's from this experiment. Let me put down Dr. H. And then this is our experiment 3. So I put experiment 3. Experiment 3. Then you click Done. Then click OK. The file should be already on your USB drive, but before you leave, you have to double check it is already there. Then this is how we check. You click File again. You click Export. Well, you do see Dr. H experiment 3.txt. Well, that means it's already there. So let's click Cancel. Then we unplug. Then let's put the legs back and the bellies as well. So then the data is in your USB drive. Then when you go home, you can turn on your computer, plug this one into your computer. You can open your Excel file to see what is being recorded.